In this video, we want to look at an example of a normal probability distribution problem. The reading speeds of 6th grade students is approximately normal with a mean speed of 125 words per minute and a standard deviation of 24 words per minute. Draw a normal model that describes the reading speed of 6th grade students. Find and interpret the probability that a randomly selected 6th grade student reads less than 100 words per minute. Find and interpret the probability that a randomly selected 6th grade student reads more than 140 words per minute. Find and interpret the probability that a randomly selected 6th grade student reads between 110 and 130 words per minute. Would it be unusual for a 6th grader to read more than 200 words per minute, and why? So we're going to look at each one of these problems on a separate sheet. So we know that we have a normal distribution. We know that the mean is 125 words per minute, and we know that the standard deviation is 24 words per minute. So if we draw our normal model for this situation, we have our variable x, which is representing the reading speeds of the 6th grade students. The mean is here in the center, 125. And if I take 125 plus 24, that is 149. That is where this inflection point occurs. And if we take 125 minus 24, that is 101. That is where this inflection point occurs. So this is our normal model that we wanted to find in Part A. Part B, we want to find the probability of randomly selecting a 6th grade student who reads less than 100 words per minute. So we want to find the probability of x being less than 100. So visually, if we look at our normal model, we have 125 here in the middle, and so 100 will be here on the left. We are looking for this area to the left of 100. Okay? Now we can find this in different ways. We're going to first find this by using traditional methods and using it by hand and using tables. Okay? So to do this, we're going to have to convert our 100 data value into a standard score, into a z-score. Now remember, we find a z-score by taking the data value minus the mean and dividing by the standard deviation. So in this case, that is 100 minus 125, the mean, divided by 24. So if we take 100 minus 125 divided by 24, that is approximately negative 1.04. Okay. So if we look at the standard normal distribution with the mean of 0 and standard deviation of 1, finding negative 1.04 on the standard normal distribution and the area to the left of that, these two areas will be the same. Now, it's only approximately the same in this case because the negative 1.04 had to be rounded. But without any rounding, these two areas would be exactly the same. Okay? So, the probability of x being less than 100 is equal to the probability of z being less than negative 1.04. At least they're approximately equal, and they're approximately equal again only because we had to round. If we didn't have to round, they would be exactly equal. Well, we can use our standard normal table. So looking up negative 1.04, so we have negative 1.04 is right here. So that is 0.1492. So this area is 0.1492. So again, that's what these two areas are. Okay, so that is our probability. So we were asked to find and interpret the probability that a randomly selected 6th grade student reads less than 100 words per minute. So if we were to randomly select a 6th grade student, there is a 0.1492 probability that that student will read less than 100 words per minute. Or another way of thinking about that is about 14.92% of 6th graders read less than 100 words per minute. So there's our two interpretations that we generally use, the probability and the proportion of the population. Now let's look at part C. In part C, we want to find and interpret the probability that a randomly selected 6th grade student reads more than 140 words per minute. So we want to find the probability of X being more than 140 words per minute. So our approach is going to be the same. So here is our model with 125 as the mean. So more than 140 words per minute, that's going to be this area here that we're looking for. Okay, so we can convert to a z-score. So z is going to equal 140 minus 125 divided by 24. Now, 140 minus 125 divided by 24, that is 0.625. I'm going to need to round that, so that would be about 0.63. So on the standard normal distribution, we're going to find the area to the right of 0.63, and these two areas are about the same. Again, I say about because if we have to round here, they won't be exactly the same. So this probability is approximately the same as the probability of z being greater than 0.63. So again, these are approximately equal. So if I look up 0.63 in our standard normal table, 0.63 has an area of 0.7357 to the left. So the area to the left here is 0.7357. So this area is approximately the same thing. So the area to the right that we're looking for is going to be 1 minus the 0.7357. And 1 minus 0.7357 is 0.2643. So if we randomly select the 6th grade student, the probability that that student reads faster or more than 140 words per minute is 0.2643. Or, in other words, about 26.43% of 6th grade students read more than 140 words per minute. Now let's continue with part D on a different page. So in part D, we want to find and interpret the probability that a randomly selected 6th grade student reads between 110 and 130 words per minute. So we want to find the probability that X is between 110 and 130 words per minute. Okay, so visually, here's X. We have 125 in the center. So 110 would be over here, and 130 would be over here. And so the probability would be this area beneath the curve. And so we're going to have to convert both 110 and 130 into z-scores. So our first z-score is going to be 110 minus 125 divided by 24. And so if we do that, that is negative 0.625, which we'll have to round to negative 0.63. Changing 130 to a z-score, 130 minus 125 divided by 24 gives us approximately 0.21. We really get 0.208333. The 3 keeps repeating, so that's going to round to 0.21. So for our standard normal distribution, here's 0, so negative 0.63 is over here, and positive 0.21 is over here. If we find the area between these, that will be the same as the area between 110 and 130. Again, approximately, and it's approximately because of rounding again. If it wasn't for rounding, these areas would be exactly the same. So we're going to find the probability that Z is between negative 0.63 and 0.21. So looking up in the table, 0.21, the area to the left of that would be 0.5832. So this area is 0.5832. And looking up negative 0.63, negative 0.63, that is 0.2643. So this area is 0.2643. So our area in between is going to be 0.5832 minus 0.2643. And 0.5832 minus 0.2643 is 0.3189. These two areas are 0.3189, and so that is our probability. So if we randomly selected a 6th grade student, the probability that they read between 110 and 130 words per minute is 0.3189. Or in other words, about 31.89% of 6th grade students read between 110 and 130 words per minute. For part E, we are asked if it would be unusual for a 6th grader to read more than 200 words per minute, and why. So to determine if that's unusual, we're going to find the probability that X is more than 200 words per minute. And if that probability is less than 0.05, then we'll call that unusual. If it's not less than 0.05, then it's not unusual. So visually, here's 125, so 200 would be over here. We want to find the area to the right of 200. So changing 200 to a z-score, we'll have 200 minus 125 divided by 24. Now 200 minus 125 divided by 24, that is 3.125, or approximately 3.13. So for our standard normal distribution, 3.13 would be here. We're going to find that area. And again, these two areas would be the same approximately. So this is approximately the same as Z being greater than 3.13. So looking up 3.13 in our table, 3.10123, that area is 0.9991 to the left. So this area is 0.9991, which means our area to the right is 1 minus that. And so that is 0.0009. That is less than 0.05, so the answer is yes, this would be unusual. It would be unusual because the probability is less than 0.05. So it's quite unusual. Now, all of these problems we could have done using either StatCrunch or the TI calculator, and so I'm going to show you how to do that on a separate video.